All right, let's look at this example. F of x equal to x to the 12 over 11 minus x to the 1 over 11. This is not a polynomial function, so calculus is really going to help us out here. Let me see, we have a part A in our notes. Our part A says, list the intervals on which f is increasing and intervals on which f is decreasing. How do I check for increasing and decreasing? Big picture. Find my derivative. Find where my derivative is equal to 0 and where it's undefined. Draw you a number line then and break it up with those numbers and use test values. So let's see. First thing I got to do is I got to find my derivative. F prime of x is equal to, that's 12 over 11, x to the what? 1 over 11 minus 1 over 11 times x to the negative 10 over 11 is my first derivative. Now I like to factor next. I can take at least 1/11th out of the coefficient of each one of those. And there are different ways to factor this. I like to take the smaller x part out basically. The one with the smaller exponent. So I'm going to factor out x to the negative 10 over 11 out of both of these. Alright, so what do I get right here for my first term? 1/11 times what gives me 12/11ths? Well, 12 first of all, right? And x to the negative 10 over 11 times x to what exponent will give me 1 over 11. In other words, negative 10 over 11 plus what gives me 1 over 11. Wouldn't that be 11 over 11? Minus, and I'm just left with a 1 here. Well, let me do a rewrite. Let me call this 1 over 11 x to the 10 over 11. In other words, bring that to my denominator and make it a positive exponent. And this I could call 12x to the first minus 1. And that's f prime of x. All right, so what do we do now? We find out where my derivative is equal to 0 and where it's undefined. So let's take this derivative. Set it equal to 0. So we're going to take each factor here, set it equal to 0. So we have this first factor, set it equal to 0, and the second factor, set it equal to 0. Well, what happens if I try to multiply both sides by my least common denominator here? I get 1 is equal to 0 and doesn't make any sense, right? How about over here? If I solve this, I get x is what? 1/12? All right, so let's see. That is where my derivative was equal to 0, that 1/12. But where's my derivative going to be undefined? This time it'll be undefined where this denominator is equal to 0. So where 11x to the 10 over 11, or my denominator, is equal to 0 will make my derivative undefined. So that's x to the 10 over 11 is equal to 0 if I divide both sides by 11. Then I could raise both sides to the 11/10ths, and I get x is equal to 0 if I do that. So 0 and 1/12 are going to be the numbers that I put on this number line for f prime. So here is f prime. I'm going to put 0 and I'm going to put 1/12 on it. Okay? All right, so now what did I do next? I used test values here, here, and here to see where the derivative was positive and where it was negative. So what I'm going to do, I'm going to run test values through here. So let's pick a test value, maybe a -1. So if I pick a -1, what is this? This is what? The 11th root. Isn't this another way to write this? The 11th root of x to the 10th like that? All right, so let's think about plugging in -1. -1, if you raise it to the 10th, that's a positive, right? 11th root of a positive is a positive, times 11 is a positive, 1 over a positive is a positive. What if I pick -1 here? What would that give me? That'll give me a negative. What's a positive times a negative? A negative right here. So what does that mean my graph of f is doing? if the slope of the tangent line is negative. That means it's decreasing. How about a test value right here? How about 0.01? 0.01. If I plug in 0.01, now raise it to the 10th and multiply by 11 and 1 over that, that'll still be a positive, right? How about 0.01 here? What would that be? Remember 0.01. So if I plug that in, that gives me what? 0.12 minus 1? What's 0.12 minus 1? A negative. What's a positive times a negative? A negative. So my function f is still decreasing there. Now let's pick a test value over here. 1 sounds good. What if I pick 1 and plug it in? I'll get a positive times a positive, which gives me a positive for my derivative, so that means my function is increasing. Now what do they want me to do here? List the intervals where it's increasing, decreasing. So increasing and decreasing. So it's increasing from 1/12 to infinity. Remember this book for increasing, decreasing uses the brackets. Where's it decreasing? All along here, right? So from negative infinity to what? 1/12. All right, so that's where my function is increasing, where it's decreasing on those intervals. Let's see, what else do we have? Find the x values of any inflection point. So they only want the x values here. All right, so what am I looking for inflection points? I'm looking for the points on the graph of f where my concavity changes, right? So if I have to find concavity, I'm going to look at a second derivative. So I'm going to take a second derivative. Now, I'm not going to take a second derivative of this part because I'll have to use a product rule and even a quotient rule. I'll take the second derivative of this part right here. That'll make my life a lot easier. So let's see. F double prime of x is the second derivative, or we can say the derivative of the derivative. So what does that give me? 12 over 121 x to the what? Negative 10 over 11 plus 10 over 121 x to the negative 21 over 11. Make sure you can do that yourself. Verify for yourself. Hit pause. Make sure you can do it. All right, let's see. Let's factor this. So let's see. What could I take out the top? At least at 2. Out the bottom, I could take 121 for the coefficient part. I like to take out the smallest exponent. If you look at Wiley, they might do it a little differently, but you can still get to the same answer. All right, so I factored out 2 over 121 x to the negative 21 over 11. So what does that give me? That gives me 6x to the, what, 11 over 11? Excuse me. Plus, that'll be 5, like that. Well, let me clean this up. Let me bring this to the denominator. So that's 2 over 121 times x to the positive 21 over 11 times 6x plus 5. There's my second derivative. Now let's find where my second derivative is equal to 0 and where it's undefined. So let's take the second derivative and set it equal to 0, or I could just set each one of these factors equal to 0. This one gives me 2 is equal to 0. That doesn't make sense. This one gives me what? X is equal to negative 5 over 6. That's where my second derivative is equal to 0. But I also need to find out where my second derivative is going to be undefined, right? When's it going to be undefined? When my denominator, 121x to the 21 over 11, is equal to 0. Says x to the 21 over 11 is equal to 0. If we raise both sides to the reciprocal exponent, we'll get x is equal to 0. Alright, so let's draw a number line here. This number line is going to be f double prime. Let's put 0 on it. And let's put negative 5, 6 on it. And then we're going to use test values. See where second derivative is positive, where it's negative. All right, let's pick a test value over here. How about negative 1? I'll put it in negative 1. Remember what this is. This is the 11th root of x to the 21st. The 11th root of negative 1 is a negative. A negative raised to the 21st power is a negative. And negative times 121 is negative. 2 divided by negative gives me a negative. What is negative 1 here? That makes it what? Negative. What's a negative times a negative? Positive. How about in here? How about negative 1/2 maybe? So if I pick a negative 1/2 and I plug it in here, I get a negative there. Negative 1/2 here will give me what? Negative 3 plus 5 is a positive. Negative times a positive is a negative. And let's see. What if I pick, say, a number over here like 1? I'll plug it in. I get a positive. And a positive times a positive is a positive. So what does that mean? We have concave up here, and concave down here, right? But they're not asking me to list the intervals where it's concave up and concave down. They're asking me for the x values of any inflection points. Concavity changes from up to down here. So x is equal to negative 5, 6. Looks like it'll be part of an inflection point. And also my concavity changes from down to up here at 0. Now be careful. These are inflection points as long as my original function is defined there. Can I plug in 0 into this original function and be defined? Yes. So that one works. What about negative 5, 6 if I plug it in here and here? Yeah, that'll work. So both of these are x values of inflection points. They're not the whole inflection point. They're not the x and y, but they are the x values of it.